day, you're welcome to Ethan's chemistry class. I'm Oracle by name. We'll be looking at atomic number and mass number. Let's assume an atom of an element as X and the atomic number to be Z and the mass number to be A. The atomic number of the atom is also equivalent to the proton number, while the mass number of the atom is equal to the proton number plus the neutron number. Remember, an atom has three fundamental particles, which are proton, neutron, and electron. The proton and the neutron of an atom is found in the nucleus of the atom, while the electron is found in the shell of the atom. Now, if we assume an element, for instance, sodium, to have Na1123, this is the atomic number of the atom sodium, while this is the mass number of the atom sodium. So the number of proton is 11, while the mass number is 23. Remember, the mass number is a sum of proton plus neutron. So it means in this 23 is 11, which is the number of proton, and in this 23 is another unknown, which is 12, because 11 plus 12 is equal to 23. So number of proton plus number of neutron equals 23. So in this atom sodium, we have 11 proton and 11 neutron. But take note, when an atom exists like this, it means the atom is existing in a neutral state. But when an atom exists like this, it means the atom is existing as an ion. When an atom is existing like this, there is something that is very important to note. What is it? The number of the positive charge particles is equal to the number of the negative charge particles. But when the atom is existing like this, the number of the positive charge particles is not equal to the number of the negative charge particles. So for this case, the number of proton, which is positively charged, is equal to the number of electrons, which is positive, which is negatively charged. So the atom of this element is existing in a neutral state. So an atom is said to be neutral when the number of protons is equal to the number of electrons. But for this case, this atom is giving out one electron. Likewise, I can have an atom of an element expressed as this. What it symbolizes is that this is a calcium ion and it's giving out two electrons. Likewise, I can have another atom like this. What it means is this is aluminum ion and it's giving out three electrons. But if the atom is not existing like this, let's see this, Cl minus. What it means is that this atom is receiving, not giving out. It's going to receive one electron. And likewise, if I have O2 minus, it means this atom is receiving two electrons. This atom as an ion is receiving one electron to become stable in its outer shell, while this is receiving two electrons to become stable in its outer shell. This is giving out two electrons to become stable in its outer shell, while this is giving out three electrons to become stable. Likewise, this is giving out one electron to become stable. Not proton, but electron. All of them is either receiving or giving out proton. Now, what about the case of checking out for the number of proton and electron? Now, if I have a case like this, Na11 plus, remember the number of proton, that's number of proton is this, which is equal to 11. The number of neutron will be gotten, number of neutron will be equal to mass number, which is this A minus the atomic number, which is Z. So it means that it will not be 23 minus 11 because your atomic number is your proton number 11, while your mass number is 23. So we have our number of neutron to be equal to 12. Now, proton number is 11, number of neutron is 12. What about the number of electron? For a neutral atom like this, the number of proton we said equal the number of electron. But for an ion, this man is going to give out one electron. Hence, the number of electron would be number of electron will be equal to 11, which was supposed to be, if it was neutral, minus the 1 it's going to give out, which equals 10. So if you compare this as an ion to this as an atom in its neutral state, it means proton number is 11, electron number is 11, but neutron number is 12. But for this case, proton number is still 11, neutron number is still 12, but electron number is not 10. Also, let's assume this calcium against calcium ion. Calcium has an atomic number of 20 and a mass number of 40. The same thing here, the same thing here. What is the difference between an atom and an ion? An ion is an atom that has charge. It's either the charge is negative or positive. But this is just an atom in a neutral state. Why is it neutral? The number of positive particles, which are called protons, is equal to the number of negative particles, which are called electrons. So that means this calcium atom has proton number equals 20. Therefore, electron number will also equals 20. Why? This atom is electrically neutral. Neutron number is equal to mass number minus proton number. So mass number, which represents as A minus number of proton. Now remember, number of proton can also be called atomic number. Number of proton can also be called atomic number. So it means it will be 40 minus 20 equals 20. Now let's compare with this. The number of proton is also this, also called the atomic number. So this is number of proton is equal 20. What about the number of neutron? I will do that first. The number of neutron, as we know, neutron number is equal the mass number minus proton number. So it will be equal to 40 minus 20. Therefore, number of neutron is equal 20. What about the electron? The electron is where we'll pay more attention to because having a plus 2 means that this atom will give out 2 electrons. Now remember, as against this, the electron number is 20. So originally, number of electron would have been equal to 20. But because it's going to give out 2 electrons to exist as an ion, therefore, it will be minus 2. So the number of electrons is now 18. I'll do a third example. This time, I will take an ion that will exist as a negative charge. Now, look at this. I have Cl as against Cl minus. This is chlorine atom, atomic number 17, mass number, it can be mass number 35 or it can be mass number 37. That will be in our next video where we'll talk about isotopes. So now if I have this as 17 and I have this as 35. Now if you go with this, we can have our number of proton, which is always this. Number of proton is equal 17. Number of proton, remember, is also called atomic number. It's 17. What about our mass number? Our mass number is 35. Let's include that in this case. Mass number equals, mass number, we know it as A. is equal to 35. Then we said our electron number is automatically 17. Why? Because this atom is electrically neutral. It does not have a charge like this because this atom is neither giving out nor receiving. The number of protons is equal to the number of electrons. So I would say the number of electrons in this number is equal to 17. What about the neutron number? The neutron number of this atom, the neutron number of this atom is equal to the mass number minus the proton number or the atomic number. So it becomes 35 minus 17. That will give us an answer of 18. Number of electron is 18. Now everything here is equal to this side except the number of electrons. Everything here is always equal to its ion, but the number of electrons is what will vary. For the other cases, you see everything is the same. Is the number of electrons that varies. On this side is 20, while in its ion is 18. On this side is 17. Now, minus 1 means it's going to receive 1 electron. So instead of 18, instead of 17, it will now be number of electrons will now be equal to 17, which ought to be plus 1, making it an answer of how many now? 18. So we have for the atom and against the ion, atomic number, which is proton number, is 17. Mass number is still 35. Number of neutron is 35 minus 17, which is 18. But number of electron isn't 17. Rather, it is 17 plus the additional one it has collected to now become 18. Now, you have a wide question and a jam question that has been asked. Element X was given and element X was given as, let's assume you have something as 17. Then you have element W. Then you have 2 minus. And let's assume you have here 16. Now the question will be, what is the atomic number of this element? What is the number of electron? What is the number of neutron of this element? This element is unknown to us. That's why it is said to be X. Now, if you ask yourself in the periodic table, which element is number 17? If you check your elements, you have hydrogen, helium, neutron, beryllium, and so on. And if you could remember very well, oxygen is 16. Then sulfur will be sulfur. Which one be now again? And wait, make I. Now it's given to us as element X and element W. So actually, whether it was given to you as X or W, what really matters is the atomic number, because the atomic number is actually the position of that element in the modern periodic table. So what this implies is that this element X is number 17 in the periodic table, while this element W is number 16 in the periodic table. Now, if you check very well, the periodic table number 17 is chlorine, while number 16 is sulfur. So now, what is the atomic number? Atomic number is the number of protons is equal to 17. Electron number, number of electron, which is still 17 because this atom is neutral, is unlike this that possesses a charge. So this again is 17. Number of neutron. Number of neutron will now be, what will be the mass number of an element, chlorine, with mass atomic number 17? It can be 35, it can be 37, depending on which of the isotopes. Why for this, which is 16, is 32. That's sulfur. The mass number for sulfur is 32. So number of neutrons would not be 35, which is mass number minus 17. The answer to this is 18. It's just like what we've done, but the difference is they closed chlorine for us and they gave it to us as X. Now for this also, number of proton is 16. Number of proton is 16. Number of neutron. Number of neutron will be 32 minus 16. 32 minus 16. That will be 16. So this will be equal to 16. But what about the number of electrons? The number of electrons will not be. What would have been if there was no minus 2 here? Number of electrons would have been 16. Now that there is not 2 minus, it means that what we're going to have is that this atom of an element is receiving 2 electrons. If it was plus, it is giving out 2 electrons. So 2 minus is receiving 2 electrons. So ordinarily it would have been 16. So number of electrons is now 16 plus 2, which equals 18. I believe you've been able to understand how to calculate number of proton, number of neutron, and number of electron in an atom of an element. Note to end this video for this section, note the sum of proton, number, and neutron number is equal to mass number. Very important. But a collection of proton and neutron in the nucleus is called Nucleon number. I'll say it again. The sum of proton and neutron equals mass number. But a collection of proton and neutron in the nucleus of an atom is called Nucleon number. Thank you very much.